Pre-Calc A, test review, sections 111 through 116. Let's go. A lot of exponents to get started. What's the rule? Well, power to a power, you multiply. Power to a power, you multiply. You can't leave your answer with a negative exponent. That's like another instruction there. So both of them are being raised to the negative power. Oh, what a great start. Busted pencil. I'll be right back. All right, so here we go. So we get 1 over m to the 4th n to the 8th. There you go. This one, we've got a situation where there's an invisible 1 here. So power to power is 2 squared. Power to power, y to the negative 2. I will take care of that in a minute. 3, do not think that this applies to the 3. It has its own little invisible 1 power, so that's times 3. Anything to the 0 power is 1. Now the only thing to a negative exponent is right there. So that is going to be shooting down. So 2 squared is 4. 4 times 3 is 12. Times 1 is 12. All over y squared. Call her good. Got to get the radical out of the basement. Multiply by the square root of 5. Don't worry about that. And then we got a little bit of oil here. Some water. Don't mix it. 4 square root of 5. Whoops. 5, that should be a 5, all over, now the roots fly off, so square root of 5 is 5, times 3 is 15. I'll rewrite that. So 4 square root of 5 all over 15. And don't forget to check this. If that can be reduced, you should. Okay, now we have a fraction raised to a negative exponent. I always like to just say, hey, take care of it right away. Put everything where it ain't, flip it. Then I'm left with a power of 3. So 3 cubed is 27, 2 cubed is 8. All right. This little problem, number 5, is trickier than you think. A lot of students think you can just square that and square that. That's a big no-no. Remember, if I go 3 plus 2 squared, and I square that as 9, square that as 4, I just got the wrong answer. Because what's 3 plus 2? 5. 5 squared is 25. I just showed you what not to do. Well, what do you do? Well, then you expand it. Just obey that. So you have to square it, which means square it. Well, now we have to FOIL. 3x times 3x is 9x squared. Outside is negative 3x. Inside, negative 3x. Negative 1, 1. Add like terms. And there you go. Breaking down square roots. Well, that one, I know. Oh, and by the way, this is oil and water. Do not multiply them. This would break down into 3. Largest perfect square root that goes into 27 is 9. This should be review. 3 times 3 times the square root of 3. Now I got some oil and oil, so that can mix. 9 square root of 3. Call it good. Now we've got a variable down here that might challenge you a little bit, but let's take care of the 32 first. Largest perfect square root, 16 times 2. Now let's follow this path. There's an invisible 2 there. How I taught it in class was, what's the first number less than that goes into? That's what we're going to chop off. That's kind of like the 16. It's the largest perfect square root that goes into this. If I took that away from b cubed, I'd be left with b. Square root of 16 is 4. I'm going to jump down to here. b, now I'm going to combine that stuff to b. And there would be my answer for number 7. Number 8 gets a little more complex, but we got a fraction, essentially, minus a fraction in the top, a fraction, plus another fraction in the bottom. So think of that as a double white line. Don't cross it. Got to have common denominators. So I'm going to multiply that by 3, that by 3. So I got 9 thirds minus 1 third is 8 thirds. Now that's the answer to the top. 4 over 1 plus 1 over 3. I'm going to multiply that by 3, that by 3. So that gives me 12 thirds plus 1 third is 11 thirds. Now when you divide a fraction by a fraction, what do you do to the denominator or the second fraction? You flip it and multiply. Whoops. That should be 3/11. These cancel, and then we swoosh, and you get 8/11. Done. Cubic roots. What's the largest perfect cubic root that goes into 24? 8. How many times? 3 times. I'm going to clean that up over here. 2 cubic root of 3. Now we got a mess over here. Don't look at this as the square root of 81. It's the cubic root. So what's the largest perfect cubic root? 27. 3 times. Now what's the cubic root of 27? 3. What's 3 times 4? 12. So I get minus 12 cubic roots of 3. And then voila, we got like radicals. So it's negative 10 cubic root of 3. A lot of algebra going on there. Okay, now I already showed you something about this. This is a no. You cannot take that, distribute it through there. You won't, it just won't work. So the question is, when does it work? Well, if it was AB squared, then you could go, aha, that's A squared B squared. See, if this stuff is connected by multiplication, then you can go power to power, power to power. But if this is plus or minus, no. So this is kind of the same thing. What if I had the square root of x squared plus, let's put some numbers in here. Let's put a 9 in there, and let's put a 25, and let's see what happens. Can I just take the square root of 9 and say 3 square root of 25 and make it 5 and say, hey, my answer is 8? Well, think about it. Isn't the square root of 64 8? What's 9 plus 25? That's not the square root of 64. That's the square root of 34. So the question is it true or false? This is false. Doesn't work. I didn't put an F by this one, so false. This one, true or false? Well, because of the negative exponent, you got to put everything inside the parentheses because that negative applies to everything. Where it ain't, and that 2 kind of comes along for the ride. Then if I square the 3, I get 9. If I square the w, I get w squared. That is true. All right, this one is piggybacking this one. You just can't distribute that through. So this is false. So that's a 1, because that times that is 1, that times that is 1. No. How about this one? 6 times 3 is 18. And then I add the exponents. Is this true or false? This would be false. Now, how do you know this? Well, remember, the rule is if the bases are the same, you add the exponents. Notice I did not multiply the bases even when they were the same. Now, if you think about it, if you had like 6 to the second power times 3 to the second power, it's asking you, is this 18 to the 4th power? I hope you can see that's false. No, it doesn't work. Okay? All right, let's keep going. Problems are going to get a little different now. So if f of x equals this, evaluate. That's just saying wherever x is, you're going to put a 3q. So I'm going to put a 3q right here. So that's 3 from here times 3q squared minus 4. Well, that's just 3 squared is 9 times 7, times 3 is 27. Q squared minus 4, and that's all you can do, so that would be your answer to this. This is saying put a plus 1 wherever you see x pop up into the function described by f, which is just right here. So I'd need to go 3 times a plus 1 squared minus 4. Now this is why it's so important to understand your true or false rules. Can I distribute that 2 to this and this? No. We got to go a plus 1, a squared. I'm going to go outside, inside, 2a. 1 times 1 is 1. I'm going to go ahead and throw that 3 that's sitting there. Oh, you can't distribute that before you square it either because of your basic rules from PEMDAS. Now I can. So I'd get 3a squared plus 6a plus 3, and that minus 4 just kind of comes along for the ride. So I get 3a squared plus 6a. 3 minus 4 is negative 1. So number 16, write the equation of a line in a point-slope form. That means y equals mx plus b. So we got to find the slope, find the y-intercept. Now they made it pretty easy. They gave us the slope, but they did mess with us by giving us a decimal. So what you might want to do is write it as 3/10 x plus b. It says it passes through 4, negative 2. So this is my x, this is my y. I need to find my y-intercept. So y from here equals 3/10 x plus b. I'm going to cross reduce a little. 2 goes into 4 twice, 2 goes into 10 5 times. So I get negative 2 equals 6/5 plus b. Subtract 6/5, subtract 6/5. Now, as you go further and further in math, they're not going to use mixed numbers, so they're not going to go negative 2 and negative 6/5. So this would be negative 10/5. That's what negative 2 is. Negative 10/5 and negative 6/5 is negative 16/5 equals b. So my final answer would be y equals, you could put 0.3 or you could put 3/10, it's the same thing, minus 16/5. There you go. Number 17. If f of x equals 2x squared plus 1, g of x equals 3x plus 2, find this. Remember, you go inside out. So we've got to find this first, which means start here. 2 times negative 1 squared plus 1. Well, negative 1 squared is 1, times 2 is 2. 2 plus 1 is 3. So that turns into 3, so now I got to find g of 3. Put this in wherever g is. So here's g, telling you to focus on this. So now I go 3 times 3 plus 2, which is 9 plus 2, which is 11. So my final answer to this whole thing is the final number that gets spit out. Now we got a review of 30, 60, 90s. Well, remember, my hypotenuse is always double my short side, so that means this has to be 6. And then you multiply that by the square root of 3, so we get 6 square root of 3. So x is 6, y is 6 square root of 3. Not too bad. 45, 45, 90, but remember, if we multiply, what do we multiply this by to get that? Square root of 2. So what do we got to do that to get back? We have to divide this by the square root of 2. And yes, you got to get that square root of 2 out of there. 10 square root of 2 over 2. That reduces to 5 square root of 2. And you know that these two are equal because it's an isosceles right triangle. So there you go. All right, probably squeeze this one in and then we'll have to start a new video. It says find the inverse. Well, the first thing you do is you realize this is y equals the square root of 3x plus 2. Now I'm going to draw a line here, and I'm going to switch these. X equals the square root of 3y plus 2. See, now we're finding the inverse, but now we got to solve for y. So I'm going to square both sides. I'm going to turn this thing around. 3y plus 2 equals x squared. Now I have to solve for y. So subtract 2, subtract 2. 3y equals x squared minus 2. Divide by 3, divide by 3. So I get y equals x squared minus 2 over 3. But the thing is, we flip-flop the x's and the y's to get here, to get here, to get here, to get here. So this doesn't equal y. This doesn't equal y and this equals y. We did the inverse, so we take that out and replace it with this. So we get inverse function is x squared minus 2 over 3. Done. All right, stay tuned to part 2.